Hi guys, welcome back. Hope you had a good weekend. Today we are starting a new lesson. We are still in section 3.1. So this is the third day that we've covered this topic, solving systems of equations. And what we've done is broken it into three parts. We did graphing last week and then substitution. So graphing is where you have two equations, you graph them and find the point where they intersect. Substitution involved isolating a variable, plugging it into the other equation and solving it. And then this third method called elimination is what we're going to be learning today. In this method, the equations will all be given in standard form and everything will be lined up. You'll see what I mean when I get there, but the x terms will be vertically above and below each other, the y terms, the equal signs, things like that. As you go, we're going to see there's generally three categories of problems. Some, are just ready to go. You'll see what I mean when I do that. There's only one like this. They're the easiest type. They're not usually what you encounter in an Algebra 2 class. The second most common, the second type is a little more difficult. It involves multiplying one equation by a number, and you have to figure out what that number is in order to make this work. And we'll get into examples where you see that. The most complicated kind, multiply both equations by numbers to make this whole system or this method work out. And those are the more complicated ones. Now you may remember this from Algebra 1. That'll be a benefit to you. Normally in Algebra 2, we review this topic and then expand on it and make it a little more difficult. This being an online class, we're probably just going to use this as a review topic, then move on to something else, to be quite honest with you. Okay. So we will still have special cases. You can have problems with no solution. With graphing, that was parallel lines. They don't intersect, so there's no solution. With substitution, when we worked it out, we got something like 5 equals 6. There's no variable left, and 5 does not equal 6. That's a false statement. So that was a sign there was no solution. Also, you can have an infinite number of solutions. With graphing, that's where you graph a line. Then when you graph the second line, it's actually the same line. So they touch each other infinitely many times. With the substitution method, you go to try to work it out, and you end up with something like 5 equals 5. Again, there's no variable to isolate, and you have a true statement. So when that happens, there's infinite solutions. Those same things are going to happen today in this elimination method. Now, to get in the right frame of mind, I want to refer you back to elementary school column addition. A problem like this where you line up big numbers, draw a line under them, put a plus sign, and then you just work vertically. 1 plus 7 is 8, 4 plus 5 is 9, 2 plus 3 is 5, 5 plus 1 is 6. And then that would be your answer. It's not that easy, but that's kind of the shape of these problems. Here's what I mean. If we look at number 2, the x terms are aligned vertically, more or less the y terms, the equal signs, the constants. They're a little slanted, but generally they're above and below each other. We're going to draw a line underneath here, put a plus sign, and then just combine these together. Negative 2x plus 2x cancels. That's 0. This is why this is called the elimination method. When you do this, two of the variables just disappear. And what you have left is 4y plus y is 5y. Then you bring down the equal sign. Ideally, it would be lined up perfectly. These are little zigzags, slanted, but whatever. Negative 10 minus 15. Negative 10 plus negative 15 is negative 25. Now, 5y equals negative 25. You can solve that. That's like pre-algebra. Divide both sides by 5. Cancels out. Negative 25 divided by 5 is negative 5. Keep in mind, your solution is going to be a point, like an xy coordinate, and we just found the y coordinate. To find the x coordinate, we're going to take this answer and back substitute it. You can plug it into either one of the original equations. It does not matter. To me, that second equation looks a little easier to work with, so that's what I'm going to do. 2x plus y, but instead of y, I'm going to put down negative 5. I'm bringing that answer up there. Equals negative 15. Oops, let me clean this up a little bit. Get rid of that arrow. It's just going to be in the way anyway. So I plug the negative 5 in for y, and then I can work this out. Add 5 to both sides. You get 2x equals negative 10, right? Negative 15 plus 5 is negative 10. Divide by 2. Negative 10 divided by 2 is also negative 5. So our answer should be the point negative 5, 5. If we graph these, that's the point where they would intersect. So number 2, let's check and make sure. And there it is. I already got the check mark by it. So just make sure your answers are in parentheses like an XY point. Okay, let's do number 1. can you see how the negative 5x plus 5x, those are going to cancel each other out. So problems 1 and 2 are what I called ready to go. You just add them up and it works out pretty directly. Now look at number 4. Is anything going to cancel out? You might think 7x and 7x cancel out, but that's not really true. What does it cancel out to take? What does it take to cancel out a 7x? I believe it takes a negative 7x. Now, can you just write a negative sign there? No, you're not allowed to change the problem to a different problem. But you can change it and still keep it the same problem. So this is what I referred to before when I said you must multiply one equation by a number. Okay, I didn't write it down, but you multiply one equation by a number. I'm going to multiply this first equation, the whole thing, by negative 1. Why would I do that? Well, like I said, if I can change one of these into a negative 7 and the other one's a positive 7, they will cancel each other out. So I'm thinking ahead, what will it take to cancel it out? But again, you can't just draw a negative sign there. You have to keep mathematical equivalence, or whatever you want to call it. So I need to distribute this whole equation with a negative 1. And let me write that over here. So negative 1 times 7x is negative 7x. Negative 1 times negative 7y is plus 7y. Bring over the equal sign. Negative 1 times negative 14 is positive 14. So I didn't just change the problem into a different problem. I changed it, but I kept mathematical equivalence there because I did the same thing on both sides of the equal sign. The second equation I do not want to change. I just want to leave it as is because, like I said, I want the x terms to cancel each other out. Negative 7x plus 7x, they cancel out, they're gone. But now I do the rest of the problem. 7y plus 8y is 15y. Bring down the equal sign. 14 minus 29 is negative 15. And as you can see, with one more step, this is solved. Y equals negative 1. Okay, it's not completely done, right? That's just the y coordinate. Now we need to find the x coordinate. So you take this negative 1 and you plug it in for y in either one of those two equations. I'm going to go ahead and do the second equation. I think I'm just picking this at random. So there, I rewrote the second equation and I plugged in the negative 1 for y. Now watch me go through the steps. 8 times negative 1 is negative 8. If I add 8 to both sides, I get 7x equals negative 21, right? Negative 29 plus 8 is negative 21. Divide by 7, x equals negative 3. And now I have the second part of my answer. So my final answer is negative 3 and negative 1. And when you go to do number 3, it's going to work out a lot like that. It might not be the x, right? It looks like you're going to have to cancel out the y's. So maybe multiply one of them by negative 1 and distribute it, and basically do the same steps I did there. All right, let me check number 4 before I go any further, because it would be embarrassing to get it wrong and have to stop the video and erase everything and start again. All right, number 6. Where am I? Here we go. Now, will anything cancel out? No. If I just stick a negative in front of something, will that make anything cancel out? No. So this problem is a little more complicated. You need to kind of think this through and think ahead and come up with a strategy that'll make this work. So here, in this part of math, you're actually having to come up with your own strategy, your own method on your own. You can't just follow a bunch of steps, cookie cutter steps, and get the answer. So here's what I see. I see negative 2x and positive 4x. And if this happened to be a negative 4 plus 4, they would cancel each other out. Again, you can't just change it to a different problem by writing a negative 4 right here. You have to do something mathematically to make that happen. So we need to multiply this equation by something. So what can you multiply negative 2 by to make it a 4? I mean a negative 4. You can multiply it by 2. If you distribute 2 times negative 2, that's going to give you negative 4x. Then you also have to distribute it here and get plus 14y, and then distribute it here and get negative 2 times 12 is 24. The second equation, you don't have to distribute anything because we want this 4x right here, so it'll cancel out with that negative 4x. So just copy it over. And let's see, maybe I can write this a little neater. So that was equals negative 24. Yeah, let's go with this now. So I made this negative 2 into a negative 4 by multiplying it by 2. That was all on me, and so that's going to be the sort of thing you need to figure out to make these work. All right, so if I combine these, negative 4x plus 4x, that cancels out. 14y plus 9y. 14 plus 9 is 23y. Negative 24 plus negative 22 is negative 46. Divide both sides by 23 to isolate y. Negative 46 divided by 23 is actually negative 2. We get a nice whole number. So that's half our answer, x comma y. So now I need to find the x. So I need to plug that negative 2 into either one of those original equations. Again, I'm going to choose the second one. It just looks easier to me. 4x plus 9 times negative 2 equals negative 22. So I put this number right there, and I'm about to work it out. So what do I do? Okay, 9 times negative 2 is negative 18. Add 18 to both sides. You get 4x equals negative 4. Divide by 4. Negative 4 divided by 4 is negative 1. So negative 1, negative 2 should be my answer. I'm curious to see if you remember learning this before or if this is brand new. Maybe make a comment somewhere, either on this video or on Classroom, and tell me. And there it is, negative 1, negative 2. All right, so looking at number 8, these are not going to automatically cancel. Those are not going to automatically cancel. We're going to have to multiply something. To me, the simplest thing is if I can stick a 2 right there, negative 2 plus 2 cancels out. So I want a 2 there. That means I need to multiply this whole equation by 2. That's going to give me 12x minus 2y equals 26. This one I don't multiply by anything. The 2y and the negative 2y are already going to cancel out. Now I work vertically. Add these together. You can put a little plus sign here if it helps. I think I forgot that on a problem. 12x plus 2 is 14x. Negative 2y plus 2y cancels out. Bring down the equal sign. 26 plus negative 12 is 14. Notice you get numbers that divide out very easily. 14 divided by 14 is 1. That is half our answer. We know what x is. We got to figure out what y is. So I guess I'm going to stick with this, pick the second problem. 2 times 1, right? I need to take out that x and replace it with a 1, plus 2y equals negative 12. Now work it out. 2 times 1 is 2. Subtract 2 to the other side. 2y equals negative 14. Divide by 2. Y equals negative 7. So that's the other half of the answer. 1 comma negative 7 should be the answer. Check number 8. And there it is, 1 negative 7. All right, let's keep trucking. Number 10. So number 10, I'll tell you, is going to be the third type of problem where you must multiply both equations by a number. So we've done a few like number 2 there. Now we're going to do number 3. Because I can't just turn a 2 into a 7 and make it cancel out with that. Or I cannot just turn an 8 into a 10 and make it cancel out with that. So what do I need to do? Well, you need to first choose. Do you want to cancel out the x or do you want to cancel out the y? There is no right answer. You can do either or. And some of the class might do it one way and some might do it the other way. And you can both be correct. I'm going to choose to cancel out the y because it just jumps out at me. It just makes sense that you can turn a 2 and a 7 both into 14, right? 2 times 7 equals 14. And this is already negative. That's already positive. So they're opposites in that sense. So I can multiply this first equation by 7 and the second equation by 2. And that's going to give me negative 14y and positive 14y. The 14s will cancel each other out. So it just took a little bit of sort of creative thought to come up with that strategy. Distribute, I get 56x minus 14y equals 7 times 24. 7 times 4 is 28, carry the 2. 7 times 2 is 14, plus 2 is 16, 168. Use a calculator if you need to. Distribute the 2 here, we get negative 10x. Here, plus 14y. Here, negative 60. Now we have minus 14y plus 14y. When I draw my line, put a plus sign, and start working this out, those will cancel each other out. The only way to make that happen was to multiply both equations by different numbers. Okay, let's go through the steps here. 56x minus 10x is 46x. 14y negative plus 14y cancels. Bring down the equal sign. 168 divided, minus 60 is 108. That doesn't look good. I'm worried I did something wrong here. Give me just a second to check my work. Oh man, I don't see it. I know I've got a problem here because when I divide by 46, 46 does not divide into 128. That is a problem. So 7 times 8, 7 times 2, 7 times... Did I do 7 times 24 wrong? 28, carry the 2, 14, 15, 16. No, that's 168. Oh, dummy. I see my mistake. All right. Rewind, back the truck up. I'm not going to stop this video and completely start over because of one mistake. If you saw the mistake, pat yourself on the back, maybe brag a little in the comments. When I distributed 2 times negative 10, should I get negative 10? No. Dum-dum. Haskell, that's negative 20. Everything else is right. 2 times 7 is 14. 2 times 30 is 60. Okay, so the rest is all good. I apologize for that mistake. Now when we work it out, 56 minus 20 is 36x. Very good. Negative 14 plus 14 cancels. Bring down the equal sign. 168 minus 60 is 108. Divide both sides by 36. And you might not recognize 108 divided by 36, but it works out just fine. It's 3. Grab a calculator if you need to on these steps. But 108 divided by 36 is a nice whole number, 3. Now to find the y value, I got to plug that into one of the first two equations. I'm going to pick the first one. 8 times 3 minus 2y equals 24. It just has fewer negatives, so it looked easier. 8 times 3 is 24. Subtract 24 on both sides. Negative 2y equals 0. Divide by negative 2. Y equals 0. So the final answer should be 3, 0. So outside of making that one little mistake, it wasn't too horrible, and there's the right answer. Let's do another one. So these we need to multiply to make the magic happen. And there's multiple strategies here. Well, let me go back to this one. I'm not going to redo this problem, make you sit through it. But, I changed this into a 14, that into a 14. I could have multiplied this by 10 and got 80, and multiplied this by 8 and got negative 80. And that would have worked. I could have even multiplied by 5 and got 40, and multiplied by 4 and got negative 40. There are different options, and they work. So in this one, I could do 3 times 8 is 24 here and here. Or I could do 4 times 10 and get 40 there and there. Or I could even go for 20, multiply this by 5 and get negative 20, multiply that by 2 and get positive 20. So there are options. I'm not going to try to confuse you by doing a whole bunch of different things all at once. That would be awful. So here's what I'm going to do. I am going to make it my goal to cancel out the x terms. I can turn 8 and 3 both into 24. One of them's already negative, so they're going to cancel. So I'm going to multiply this first equation by 3 and the second equation by 8. This one becomes negative 24x minus 12y equals negative 72. Then I distribute here, I get 24x plus 80y equals, oh no, 8 times 26. So I don't want to screw this up. 8 times 26. Grab a calculator if you need to. 16 plus 4 is 20, 208. Scary. We're getting big numbers here. Hopefully we'll be okay. Now we want to combine these equations together. Negative 24 plus 24 cancels. Negative 12y plus 80y is going to be 68y. 208 plus negative 72 is going to be 136. That might not look good to you, but I'm telling you it will divide. No, that won't. Yeah, that'll divide out, right? Sure. 136 divided by 68 is 2. Plain and simple. So half of my answer, the y half, is 2. Now we got to find the x half. I'll go ahead and take the second equation. 3x plus 10 times 2 equals 26. Since we solved for y, we plug y into one of the equations, and it could be either one. It's up to you. I picked the one with fewer negatives. 3x plus 10 times 2 is 20 equals 26. The rest is fairly basic algebra, which I'm confident you can do. Divide by 3, x equals 2. So the final answer should be the point 2, comma 2 for number 12. Scroll down too far. There it is, 2, 2. Okay, now we're getting into the special ones. These do not take long at all. All right, so choose a variable to eliminate. Let's say I want to eliminate the x's. I can multiply this first equation by negative 2, right? Negative 2 times 6 is negative 12. Negative 12 plus 12, that's going to cancel. So that's what I'm going to do. I'm going to distribute, oops, well, that was a mess. Let me start over. I'm going to distribute this equation by negative 2 in order to get a negative 12x. Then I also get negative 14y equals negative 2. This one I don't have to distribute anything because it's already got a 12x. So this is like the second type of problem where you only have to multiply one equation by a number. Now, let me make that 0 look more like a 0. I don't want you to think it was a 6. Now, draw a line and add these up. Negative 12x plus 12x cancels. Negative 14y plus 14y also cancels. The variable's gone. What's left? Nothing. 0. Negative 2 plus 10, that's 8. So if there's no variable left, you cannot solve this completely. Then ask yourself, does 0 equal 8? No, that's a false statement. Remember, false statements mean no solution. Or if you prefer, you can use the no solution symbol. So number 14, right there, no solution. Notice when you get a no solution, you don't have to do all of this extra work like you do in the other problems. It's just that. All right, let's look at number 16. Again, let's say I want to cancel out the x terms. So I'm going to multiply this by 3, right? 3 times 10 is 30. 30 and negative 30 cancel. So that's my strategy. That's what you got to come up with, a strategy to do this. So if I multiply by 3, I get 30x. Distribute here, I get minus 3y. There's an equal sign. 3 times negative 7, negative 21. This one, the second equation, I don't need to distribute anything because that negative 30 is already there. Negative 30x plus 3y equals 21. Now, do you see what's going to happen here when I add them up? Negative 30 plus 30 cancels. Negative 3y plus 3y cancels. Nothing left, 0. Negative 21 plus 21 cancels, 0. There's no variable left to isolate, so you can't completely work this out like the rest of the problems. So you just look at the result. Does 0 equal 0? Yeah, this is a true statement. When you get a true statement, that means there's an infinite number of solutions. So I'm going to abbreviate infinite solutions like that. Number 16, there it is, infinite solutions. Okay, so let me summarize. You're solving systems of equations. We're using this elimination method. You should have learned it before in Algebra 1. If not, this is your first try. You can get this. The first problem is set up so that if you just combine them, things cancel and it works right out. So it starts out easy. The next couple equations, you're going to have to multiply one of the equations by something to make opposites that cancel, but only one of the equations. This one, maybe what you could multiply this by something to make it cancel out with a -9, perhaps. That's something you might want to do. Then you get into equations where you need to multiply both by something to make stuff cancel out. Follow my examples for notes. When you get to the bottom, you will get some with a false statement, another one with a true statement, so no solution, infinite solutions. Here, I should circle that. All right, I'm going to stop there. If you have trouble, any difficulty at all, text me through the comments or send me an email and I'll do my best to help you. Otherwise,